All right, so let's look at just a couple examples of using an integrating factor. So here's a differential equation. And the first thing to learn from this differential equation is it certainly looks like it doesn't fit our pattern. Remember what our pattern needs to be. It needs to be dy dx plus some function of x times y equals some function of x. This one looks a little more complicated, but it does not take much to put it into this right form, which is then eligible to be solved by using an integrating factor. In fact, the big thing we notice is, hey, I can't have any coefficient on the y prime. So that's the first thing I've got to do. And hopefully just by getting rid of that coefficient on the y prime, I can get into the form that I need. Y prime plus 3 over x times y equals 2x to the fourth. And we'll just remember our initial condition. But there it is. That fits the pattern. All right. So we need to calculate our integrating factor rho, and it's going to be e to the integral of 3 over x dx. So, what we really need to calculate is the integral of 3 over x dx, and that of course is 3 ln of x. And we don't worry about the absolute values, and we are not going to put a plus c in there. Okay, so 3 ln of x. Now, you could, and it may be useful to write that as this is also equal to 3 ln, or sorry, this is also equal to ln of x cubed, right, using properties of logarithms. But we're not going to go quite that far yet. We'll see if we need to. We just want to remember that. For now, we're just going to stick with what we get right out of the tap, right? So that's going to be what we multiply by. We'll multiply the left-hand side by that. And we'll multiply the right-hand side by that. And right now, this is the thing that sometimes it's hard for students to grasp. Right now, you can just integrate. You can just, boom, integrate this with respect to dx, integrate this side with respect to dx. Okay? The reason we do that is because that left side, we know already what the integral of that complicated expression is going to be. It's going to be y. We'll just leave it as y times e to the integrating factor, 3 ln of x. And here's where I think we would prefer to have ln of x cubed, because if that's ln of x cubed, I'll squeeze it in here, y e to the ln of x cubed, then that is the same as just y x cubed, right? Because e raised to the ln x cubed is just x cubed, because e and natural log are inverses. Okay, so let's get on to our expression here. This right-hand side is really the work we have to do. Can we evaluate that? And that's the question we're after right now. We've got to be able to evaluate that. We can decide whether we want to put that 3 inside or outside. Let's leave it outside for the time being and see what happens, because it's just going to be easier to not have to deal with it inside as an x cubed. Now this particular integral looks like it is complicated enough. Again, our hierarchy of approaches is power rule first. Now there's no way this is going to do the power rule. U substitution as our next method for integration. And remember, with U substitution you need a U, and then you need to see the derivative of that U as part of the integrand, and it is not there. And then you need and then if none of those works, then we look at integration by parts. So let's see if we can do this. Right now this is where we're at. We're just at y cubed equals this right hand side. So I'm just going to box that off so we don't lose our progress. That's where we're at. We're going to take a little side trip as we work to integrate. So this is a little side trip as we work to integrate 3 ln of x to x to the 4th dx. First thing I'm going to do is I'm going to bring both coefficients out and make it a 6 times, and I'm just going to rearrange it. That way there's no confusion. And there it is, right? Just swapping the ln of x and x to the 4th. Okay, so now we're going to try integration by parts. U and dv, right? And what do we choose for what? Well, it depends on which one is going to be easier to work with. I think it's going to be easier for us to have ln there, because if I put ln as dv, I've got to integrate it. And the integral of ln is not simple. It gets more complicated. So that means that dv is x to the 4th dx. And if we run this through, du is 1 over x, that's nice, dx. And v is x to the 5th over 5. So, working this through, that integral is going to be 6 times uv, right? So that's going to be 1/5 x to the 5th ln of x minus the integral of v du, right? Minus the integral of v du. So the integral of v du is going to be, we'll write it here. Let's go 1 over x, there's du, x to the 5th over 5 dx, right? And I'm liking what I'm seeing there, because that's just going to be, let me just do a little aside here, that's just going to be 1/5 integral of x to the 4th dx, which is just going to equal, what, 1 over 25 x to the 5th plus c, right? And we do need a plus c at this point. 1 over, yeah, so that's this piece right here. So we've got it. We've got our integral. It's 6/5 x to the 5th ln of x. I'm distributing that 6 through because I know it's going to have to come in. Minus 6/25 x to the 5th plus, and you might say, oh, well, don't I hit the 6 times the c? And yes, I do, but that still just makes it a different constant. So just to keep that, we'll put c1. And if you really need to keep track of it, you realize, oh, c1 is just the 6 times the c. But it doesn't matter, it's just there. So that's the right hand side. That's the thing that goes right here. All right, so we'll put a little, that goes right there. And now we've got we are solved, with the exception of some cleaning up, right? Some simplification. Right? And by simplification, that I mean I just want, if I can, I want to just solve for y, and I can in this case just divide everything by x cubed. So that makes that an x squared. Now notice this is no big deal. This is x squared as well. But notice what we get here. This c sub 1 becomes no longer just a constant term. It becomes an actual x term. And so that's important that we don't just drop the c, because that is going to become an extra term. And you know what? Let's see. If we want to then continue to solve for our initial value, which is 2 comma 1, right? Let's do that over here on the side. So I get out a 1 if I plug in a 2. Right? And so we get 1 equals, what's that, 24 over 5 ln of 2 minus 24 over 8. It's not pretty. 1/8 times is what it's going to be, right? 1 minus 24/5 ln of 2 minus 24/5. And that's C sub 1. All right, and I'll let you throw that into your calculator and put that right there. But there it is. So you see, there's an example of another example of solving using an integrating factor. And it's powerful. It gives us access to solve the ability to solve a whole new family of differential equations, and gives us a powerful tool.